Alright, complex numbers. No solution? If you try and tackle this problem, you should get undo the 9, minus 9, minus 9. So you can have 2x squared equals a negative 4. Then undo the times 2. Divide 2, divide 2. You should have this. X squared equals a negative 2. Okay, now right here, hopefully your eyeballs see you're in trouble. What number times itself is going to be a negative 2? Nothing. Your answer is no real answer. No real answer. So if you undo the square, if you square root both sides, you can have this. X equals the square root of a negative 2. And you can never take the square root of a negative number, because any number times itself is always going to be positive. So this right here, your eyes have got to see that and recognize that there's no real answer. That is an impossible feat. So, up until 400 years ago, we were done right here. We could not go beyond this point. As soon as you got the square root of a negative number, mathematics was stopped. But this guy, René Descartes, he's a French mathematician. He figured out that we could go beyond this limit. And as soon as you are on a new frontier and you open up a new frontier, then mathematics advances and all sorts of perks come to us anytime mathematics advances. So, this was the limit. Couldn't go beyond here. Here is how we now go beyond here. He said there exists a whole set of numbers that is not real. And he's going to call them the imaginary numbers. So our number line right here, this is the number line we use and we're familiar with. 0, and even between 0 and 1, there's an infinite number. There's 0.1, 0.11, 0.111. There's decimals, fractions, square roots. Everything fits on here. Our real number line. Do you remember this? The set of all real numbers, that abbreviation? That is the world we live in. The set of all real numbers. Any number in this set is found on the number line. Square root of 2 is somewhere between 1 and 2. It's 1 point. It's a decimal. Even pi is on this number line. So, an imaginary number is something up here or down here. It is not on our number line. You cannot find these imaginary numbers on our number line. So here's the two things you've got to memorize right here. Everybody box them. I is the first letter in the word imaginary, so we're going to call it I. I is equal to the square root of a negative 1. And this is called the imaginary unit. So numbers of this form right here, you see these guys right here, 3i. 3i is an imaginary number. It is not in our set of real numbers. It's not a decimal, it's not a fraction, it's not a negative, it's just an imaginary number. A negative 5i, anytime you see the I, look at this one, I times the square root of 2. These are all imaginary numbers. And these ones are pure imaginary numbers. Pure imaginary numbers are the square roots of negative numbers. So these are all the square roots of a negative number. So this guy right here, if you get this for an answer, the square root of a negative number, we are going to teach you how to change it to an imaginary number. So right here, this one, probably most importantly, do you see how it says I squared is equal to a negative 1? Okay, I squared is equal to our version of a negative 1. So this imaginary number squared equals our real number, negative 1. And this is super helpful. So now we're just going to teach you how to do operations. We're going to teach you how to add, minus, times, divide in the set of complex numbers. So here we go. Square root of a negative 18. This assignment's from the book and I tried to take samples of each section. So if you get home and forget how to do it, I also tried to write notes up here to help you remember the steps. So if you are asked to simplify the square root of negative 18, here's your plan of attack. Rewrite the radical as the product of two radicals. So here we go. Move number one. You're going to write the product of two radicals. So radical times a radical. One of them is going to be the square root of a negative 1. So very first thing you're going to do, if you ever come across the square root of negative 18, it's going to be rewritten as the square root of negative 1 times what? Times the square root of 18. Now this is a real number. Square root of 18 is a real number. We know how to use that, manipulate it, play with it. Let's do that right now. What's the square root of 18? If you're asked to simplify square root of 18, what are you going to get? Is there a perfect square in 18? Can you divide 18 by 16, 9, 4? You can divide it by 9. So let's rewrite the square root of 18. Let's rewrite that as the square root of 9 times the square root of 2. And what is the square root of 9? So that's a whole number, 3. So you've got 3 times the square root of 2. That is the same thing as the square root of 18, but it's simplified. Now, what about this square root of negative 1? What are we going to change that to? That is I. So you're going to have I times 3 times the square root of 2. So your final answer is this: 3i times the square root of 2. You always put your number first, then the letter. Did you get square root of negative 1 times square root of 125 x to the 5th? And then, right off the bat, you can see this square root of negative 1. Let's replace it with I. So we're going to replace this with I. That's going to equal I times. What about the square root of 125? Can you simplify that? Square root of 25 times the square root of 5. And then we still got times the square root of x to the 5th. What's the square root of 25? So here's what we got. We've got 5i times the square root of 5 times the square root of x to the 5th. What about these x's? How many of these x's are going to make it out? How many are going to stay in? So take your exponent, divide by your index. 5 divided by 2 is going to be 2. So x squared come out, and how many stay in? So your final answer should be this. Outside of the radical, you're going to have a 5x squared I. Underneath the square root, you're going to have 5x. Did you get that? Okay, now, so that's your easiest. You're going to start simplifying them. Then we're going to do some multiplication, addition, subtraction, division. Let's multiply them. Number 1, follow your steps. If you're going to multiply two imaginary numbers, first, you've got to rewrite them as the product of two radicals. One of them's got to be the square root of a negative 1. So if you ever come across the square root of a negative 10, you're going to rewrite it as square root of a negative 1 times square root of 10. And then you're going to do the same thing to the square root of negative 15. You're going to go times, since it's all big times problem, square root of a negative 1 times square root of a negative 15. Now let's replace the square root of a negative 1. What's the same thing as the square root of a negative 1? I. So you're going to go I times the square root of 10 times I times the square root of, that should be a positive 15. Let me erase that. So here's what we got. I times the square root of 10 times I times the square root of 15. What is I times I going to be? So your third move is going to be outside of the radicals. You're going to have I squared. What are you going to have underneath the radical? Let's multiply. What's 10 times 15? So you can legally multiply those two radicals together. 10 times 15 is going to be 150. So you got I squared times the square root of 150. Can you clean up the square root of 150? Is there a perfect square in 150? Can you divide it by 144, 121, 100, 81, 64, 49, 36, 25? So let's keep going. I'm going to go horizontal. So you got I squared times the square root of 25 multiplied by what? 25 times what's 150? 6? Okay, what's the square root of 25? So here's what we got. We've got I squared. I broke up 150 as 25 times 6. And it's legal. You can rewrite the square root of 150 as the product of two numbers. And now I chose 25 because 25 is a perfect square. So if I rewrite it like this, you're going to get I squared times 5 times square root of 6. Now here's what you love. Anytime you come across an I squared, that's an imaginary number. You love it. But it is equivalent to our number, -1. So this is a -1 times 5. What's -1 times 5? Our answer is a -5 times the square root of 6. Alright, let's try the middle one. Let me erase all this stuff. What about this one? What about -2i times 7i? What's that going to be? -14i squared. So they're just like our variables. I times I is going to be I squared. You manipulate them the same way. But what is I squared? So this is a -14 times a -1, which is just a positive 14. Okay, what about the third one? What about this guy? What about 3i times the quantity -5i squared? What do you want to do first on that one? You got to do the exponents first. You got to do exponents first. So you have got to do a -5i times itself, a -5i. So what's -5 times -5? So you're going to have 25. What's I times I? I squared. But what is I squared? So what's 25 times a -1? So here's what you got. You've got 3i times a -25. So now let's multiply your numbers. What's 3 times a -25? 75. -75i is your answer. Okay, last concept and we'll call it good. These are pretty fun. So you're going to simplify a power of I. There's 4 types of problems here. I to the 45th, I to the 37th, I to the 42nd, I to the 20th. Here's your game plan. So you can read through them. If you read through them right now, they don't make any sense. But here's what they say. Here's what you do know. You do know I squared equals -1. Everything is going to be based off of this fact. So how many of these I squares are in I to the 45th? So if you have an odd exponent, here's what you do. If the exponent is odd, rewrite the power as the product of two powers. I'm going to write it as I to the 1 times I to the 44. Because when you multiply these powers, you add the exponents. So I to the 45th is the exact same thing as I to the 1 times I to the 44. Now, I'm in search of this. I'm in search of an I squared. So here we go. I'm going to go I to the 1 times I squared raised to the what power? Raised to the 22nd power. Because when you raise exponents to another level, you times them. So I to the 44th is exactly the same as I squared to the 22nd power. Now this is pretty clever because here's what you got. You've got I times a negative 1 to the 22nd power. So if I do a negative 1 times itself 22 times, what do I get? You're going to get a positive 1. So your final answer is I times a positive 1, or just I. So I to the 45th is equal to I. Okay, let's try the same thing on I to the 37. I to the 37. Step number 1. Rewrite it as the product of two powers. I to the 1 times I to the 36. Because 36 plus 1 is 37. So these are two equivalent expressions. Step number 2. Let's rewrite it as I to the 1 times I squared to the what? To the 18th. Because I'm looking for an I squared. Because I know that I squared is equal to our negative 1. So I can rewrite it as the I squared raised to the 18th power. So this one is just going to be the same as before. It's going to be I times a negative 1 to the 18th. A negative 1 to the 18th power is going to be a positive 1. So just put I. Now if they're even, look what happens if they're even. Let me erase this stuff. If they are even, I to the 42nd, how are you going to rewrite that? I squared to the what power? It's going to be to the 20. What's 42 divided by 2? 21st. So you just rewrite it, express it in terms of I squared. So I squared to the 21st power, and what is I squared? So it's going to be a negative 1 to the 21st power. What's a negative 1 times itself 21 times? It's just going to be a negative 1. So I to the 42nd power is equal to a negative 1. What about I to the 20th power? It's going to be I squared to the what power? To the 10th? What's I squared? So this is going to be a negative 1 to the 10th power. What's negative 1 to the 10th power? What's a negative 1 times itself 10 times? Just a positive 1. Those are